Hi everyone. So in today's session, we will see the introduction to the power semiconductor drives. So basically, this is a program elective course with a code WPE13. Coming to the objectives of the course, this course will develop students' knowledge on the fundamentals and dynamics of electrical drives and the various types of rectifier control and chopper control drives. That means DC drives. So how to control that DC drives along with the fundamentals and dynamics means transient, steady state operations, all those things. And AC voltage control, frequency control, and slip power recovery control of induction motor drives. So this is basically dealing with the AC drives. Second point is with respect to the DC drives, how to control the DC drives that you are able to learn. And third point is regarding the AC drives. In AC again, it is induction motor drives. Along with that, the last point is various types of synchronous motor drives and its speed torque characteristics. So, you are going to learn fundamentals, that is steady state, transient operation, or dynamic, as well as the DC control drives, AC control drives, and for all these drives we will see the speed torque characteristics. Generally in machines you might have learned speed torque characteristics, but those are static or fixed speed torque characteristics. By including the converter, you are able to control the speed. That means you can get the different or multiple speed torque characteristics lines by controlling the firing angle of the converter. So that is the advantage of power converters here. So power converters are used to control the speed torque characteristics. As per the load requirement, you can get the speed torque characteristics by using these converters. Now this converter plus motor is nothing but drive. If it is converter plus DC motor, that is DC drive. If converter plus AC motor, that is AC drives. So converter means including the controlling part. Okay. So coming to the outcomes of the course, at the end of the course, the students will be able to learn or understand the fundamentals and dynamics of these electric drives. You are able to learn or develop the rectifier control, how the rectifier control and chopper control will be there for DC drives. Along with that, realize the concept of AC voltage control, frequency control, and slip power recovery control of induction motor drives, and with few numericals. In all the cases, we will do the numericals also. But if you solve few numericals means you can understand in a better way what is happening in that controlling. And know the concept of synchronous motor drives along with few numericals. These numericals generally, to understand the concept in deeper, we'll go for that numericals. So the outcomes of the course, at the end of this course, you are able to learn or you are able to develop these concepts. Coming to the contents of the course, so there are total 5 units. In the first unit, basically, we will cover the fundamentals of electric drives. Fundamentals of electric drives, in that generally what is meant by drive and what is meant by electric drive, normal drive, electric drive, and what are the advantages of electric drives, and what are the parts of electric drives. So what are the advantages, what are the parts of electric drives, and what are the choices of electric drives. Generally, what are the choices how can we prefer, and what are the choices of electric drives, that we'll see. And what is the present status of DC drives and AC drives, to understand in a better way, or to know the future or present status. What is the present status of AC drives as well as the DC drives? Along with that, we'll see the starting methods, how to start the electric drives, how to apply the braking of electric drives, and also speed control of AC and DC motors. See, electric drives, right, consist of motors. Motors, we need to start, we need to apply brake, we need to control the speed also. So if you know these things, then we can go for the controlling with converters. Okay, that we'll see in further units. Coming to the second unit, there we will see the dynamics of electric drives. So in dynamics of electric drives, generally we'll go with the fundamental torque equations. This fundamental torque equation is important because by using this fundamental torque equation only, we are going to draw the speed torque characteristics. So that's why fundamental torque equations. And what are the types of loads? Various types of loads. And the quadrant diagram of speed torque characteristics. That means quadrant diagram means there are 4 quadrants, right? In xy plane, if you take speed on x-axis, torque on y-axis, first quadrant, second quadrant, third quadrant, fourth quadrant, respectively. First quadrant means both positive speed as well as positive torque. That means forward motoring you will get. If you want to operate the motor with, or if motor is operating with positive speed and positive torque, then that is in forward motoring condition. If you reverse the motor speed by doing some power electronic, with the power electronic converters, then that will enter into the second quadrant. By keeping the torque in the positive direction only, we are reversing the speed. Then it is in the second quadrant now. When you are reversing the speed, slowly you are applying the brakes. That's why it will enter into the forward braking mode. When your both torque and speed are in reverse, then it will enter into the third quadrant. There, that enters into the reverse motoring mode. Now from reverse motoring mode, again, if you reverse the speed, now the speed is with the negative direction. If you bring that speed into the positive direction, that is a reversal of speed, right? It will go to the fourth quadrant. That becomes the reverse braking. So these things we'll see by drawing the characteristics also. If you understand that fundamental torque equation, from there only we will draw the characteristics. Okay. And what are the dynamics of low torque, steady state stability, transient stability of electric drives, stability part also we'll see with respect to the electric drives, load equalization, calculation of time and energy loss in transient operation, along with the drive specifications. Means calculation of time and energy loss means in transient operation, when you are starting or when you are applying the braking or when you are going for speed reversal. So all these are the transient operation. Starting, braking, speed reversal are the transient operation. During that time, how much time it is taking to do that operation or to bringing into that operation, that may be braking or starting or speed reversal. How much time it is taking and how much energy loss is there. Those calculations also we'll see. Okay. And coming to the third unit, control of DC drives. Control of DC drives means here basically DC motors will use to control the DC motors. We need to use the DC converters. That is nothing but which if your supply is AC, you need to use the rectifier which will convert the AC to DC, and to output DC will be connected to the DC motors. If your supply is DC, you need to connect the DC to DC converter. Output DC will be connected again to the DC motors. So control the rectifier circuits, and by using the rectifiers, how can we get the braking operation of the rectifier control? Separately excited DC motors. Then we will see the separately excited DC motors. In single phase and three phase, half wave, full wave control rectifier fed separately excited DC motors. So these things we will see. Generally rectifier will give always positive current. That means unidirectional current. Generally rectifier means it is two quadrant converter, right? What are the two quadrants? Rectifier always it gives unidirectional current with positive as well as a negative voltage. That means if it gives positive current, and by controlling the firing angle within the 0 to 90 degrees, your voltage will be positive. If your firing angle is between 90 to 180 degrees, your voltage will be negative. But your current is always positive. So with that, you are able to get forward motoring as well as the forward braking operation. Two quadrant operation you will get. But if you want to go for multi-quadrant operation, what we need to do? We need to connect the converters back to back, rectifier and inverter combo. So there you can operate the rectifier from 0 to 180 degrees as well as the inverter also from 0 to 180 degrees. When you are operating rectifier, it will be the positive direction of current. When you are operating the inverter, it will be the negative direction of current. Okay. With that, you can get the four quadrant of operation. Entire this drive subject, you need to observe that speed torque characteristics only. How to control the speed torque characteristic, that's what we will see. Okay. So with the rectifiers, two quadrant operation as well as the four quadrant operation we will see for the DC drives. Along with that, to control the DC motors, we have another converter, that is DC choppers. That is the DC to DC converter. So again, by using this chopper control of DC drives also, chopper control of separately excited as well as series DC motors. For that, two quadrant as well as the multi-quadrant operation. That is all four quadrant of operation. That is forward motoring, forward braking, reverse motoring, and reverse braking operations we'll see. In the third unit, we'll see all those things. In the fourth unit, control of induction motor drives. Fourth and fifth units are related to the AC drives. So fourth one is we'll see control of induction motor drives. Fifth one is control of synchronous motor drives. In control of induction motor drives, to control the induction motors, we will see control of induction motor by using AC voltage controller. By using AC voltage controller, your voltage alone is controlled. To control the frequency, again frequency control induction motor drives with the voltage source inverter. There you can adjust the frequency also. And current control PWM inverters and cyclo converters to adjust the voltage and frequency. These converters will use AC converters. And slip power control wound rotor induction motor drives like static rotor resistance, static shape gears drive, Kramer drive, all those things. How to control soft control, that is nothing but soft switching control. Just by using a converter, how to control the characteristics. In the last unit is fifth unit, that is control of synchronous motor drives. In control of synchronous motor drives, we will see the operation of cylindrical rotor synchronous motor from voltage source inverter as well as a current source inverter. In self-controlled synchronous motor drives, self-controlled true synchronous mode, self-synchronous mode, those concepts we will see in the last unit along with the permanent magnet AC motor drives. Okay, this is the syllabus of power semiconductor drives, what we will see in further classes. So here you can follow these few references. That is coming to the textbooks. One good textbook is Fundamentals of Electrical Drives by G.K. Dubey. So this covers almost all the topics related to the first and second units. And most of the concept you can get it from these Fundamentals of Electrical Drives. And Electrical Drives by N.K. Day and P.K. Sen. So these are the main textbooks. And coming to the reference textbooks, so the thyristor control of electrical drives by Vedan Subramaniam and modern power electronics and AC drives by B.K. Bose and power electronics by P.S. Bimla, because you need to know the power electronic concepts also. To understand the power semiconductor drives, you should know the power electronic concepts. In power semiconductor drives by G.K. Dubey, along with that, one NPTEL course also there, okay, on fundamentals of electrical drives. So in further classes we'll see these concepts one by one. Thank you all.